I'm Professor Jinsul from Chonnam National University. Today I will present on the topic, transforming the energy sector with AI, some challenging issue and solution. So at the AI Innovation Hub, we researching under the theme of meta-energy intelligence. So our work focus on developing various solutions to address challenging the energy industry and everyday life. So as you look at this slide, our research group include 15 professors collaborating from a lot of institutions such as Chonnam National University and GST and Jeonbuk National University and Caltech, Seoul National University and Sungsil University and then Hanyang University. So today I will introduce some of why we need the research about energy AI. So I briefly explain the need for the research, and then I will introduce some focusing on the three main topics as you look at it. So the AI is and the energy AI is there's a lot of issue because the data is kind of different depending on the environment and any circumstance. So the reason for the integrating AI into the energy sector is very clear. So energy industry operates within the complex data. As I look at that, some of very complex environment, and they involve the wide range of the stakeholders, make advanced data analysis technology essential. So AI has emerging as a powerful tool to address those challenges. For example, AI can predict the power demand and or the analyze energy consumption, so patterns to maximize energy efficiency. However, to fully harness the benefit of AI in the energy sector, we must overcome the several unique challenges. So our research the aim to enhance the efficiency and sustainability and the decision-making process within the energy industry. So we refer to this technology collectively as a meta-energy intelligence. So as you look at the slides, the right side is some of deep learning can overcome and analyze a pattern within the power data. And then power facility image data often imperceptibly able to the naked eye can inspect it efficiently, especially in the vast area like solar side using drone vision any data. So time series data can reveal hidden characteristics specific to different time zone, including time zone 1, 2, 3. So we try to and explore the deep learning technique to provide the dependable outcome for critical managerial decision. So let's look at that one video clip from YouTube. This is from NBC.
Demand has never been higher for these racks and racks of powerful servers feeding the internet's insatiable appetite for computing in the cloud.
The reality is that the cloud is not up there somewhere It's right here. We are in it. You're in the middle of the cloud as we speak.
And data centers like this can't ever stop. Streaming, social media, photo storage, and more recently, and requiring much more data, training and running chatbots like OpenAI's ChatGPT, Google's Gemini, and Microsoft's Copilot.
And you can feel the heat coming off of these.
Thanks to the generative AI race, data centers like this are springing up as quickly as companies like Vantage can build them. And that means demand for power to run them and cool them is through the roof too.
If we don't start thinking about this power problem differently now, we're never going to see the stream we have or the potential we have of this amazing technology that can truly change our lives.
One ChatGPT query takes nearly 10 times as much energy as a typical Google search, and as much energy as keeping a 5-watt LED bulb on for an hour. Generating an AI image can use as much power as charging your smartphone. Hyperscalers building data centers to accommodate AI have seen emissions skyrocket. And this problem isn't new. Estimates way back in 2019 found training one large language model produced as much CO2 as the entire lifetime of 5 gas-powered cars. And even if we can generate enough power, our aging grid is increasingly unable to handle the load.
Yeah, this video clips actually discussed the content from the CNBC, how the massive power draw of generative AI is overtaxing our current grid. So, yeah, this is one of the reasons why we need energy AI. So, recent advancement is AI advancement in AI have led to the increasing utilization of data center. For example, a single ChatGPT query consumes about 10 times the energy of a typical Google search. So as AI continues to developing, it is imperative to address the concern regarding energy consumption and environmental impact. So energy AI processes the vast amount of energy data and uncovering patterns that are challenging for human to analyze directly. So this capability of allow for early detection of potential issue and implementation of the preventive measure. AI's role extended beyond the merely enhancing efficiency. It is also contributes to achieving sustainable energy management. So our first object is cross-domain energy management. So energy data is often collected from diverse domains, making it challenging to analyze the interaction between data sets. So to address this issue, our research focuses on the developing technology that enable integrate the management and the utilization of the cross-domain data. So our second object is a high-dimensional energy data transformation. So energy data is a highly multidimensional, and then transforming it into and then analyze the format presents a significant challenge. So we are exploring new transformation technique to efficiently handle high-dimensional data. So this is our third object. We try to, first of all, try to understanding the energy phenomena. So this involved the developing technique to comprehend energy phenomena, which are critical for making fact-based decision in the energy field. So leveraging natural language processing technique, also we aim to decode complex pattern in the energy data, ultimately support human decision making within the energy sector. So we aim to help human decision making through energy knowledge graph or the multimodal meta learning that can be extracted from energy text and time series data and multimodal heterogeneous data. So, this is our ultimate goal of our research is to achieve the human level energy technology in the energy sector. So this refers to technology that analyze the complex energy data beyond the intuitive grasp of human and then transform it into a format that accessible and then actionable for human use. So by leveraging AI-based energy technology, we aimed to analyze the pattern in energy data and then extract the valuable insight to drive meaningful advancement in this field. So we aimed to extract energy knowledge from diverse industry data to aid decision making and then develop human level energy prediction and management technology using deep learning derivative meta dimension and cognitive experience data. So those technology hold great promise and can contribute to various benefits, including energy efficiency improvement and energy supply and demand prediction and energy grid management and cost reduction and environmental protection and ultimately promotion of sustainable energy production and use. Through these efforts, we aim to impact the diverse industry and sector, fostering a greener planet. So now, let's introduce some of our research projects. With the rapid growth in the number of electric vehicles, the need for efficient charging scheduling has become also increased important. In this context, we have developed an algorithm and to optimize the EV electric vehicle charging to reduce the cost. So our approach combined the two methods, the low price pursuit algorithm and then selective extra charging algorithm. And this integration approach efficiently reduce the charging cost while improving efficiency. So using these algorithms, we achieve to the 5% reduction in the charging cost and improve the charging efficiency by up to 39%. As shown in the graph on the slide, on the right side, our proposed method is our perform conventional approach in the both cost and efficient metric. Okay, next, I will introduce our research on detecting faults in the energy equipment. There are a lot of energy equipment to provide energy and consume the energy. So energy equipment often operates in the extreme environment where the challenging, such as communication, failure, reading to the data collection issue, and the anomaly are also common is happening. So we design on the AI-based method capable of detection fault with high accuracy, even on the low spec equipment. So Nat'l, by leveraging the auxiliary learning and then contrastive learning technique, our approach ensure reliable fault detection even under the adverse weather condition. So the image on the right illustrated the architecture of this model. So this research actually significantly improved the accuracy of fault detection in energy equipment and contributes to enhancing equipment uptime. So the result of this study have been published in the two top SCI journal and ranked in the top 10% in their field. And the technology is expected to make a sustainable impact on the reduce and maintain cost per energy system. So next, we have also conduct the research on the data publication and restoration technology to enhance the reliability of energy data. When data is compromised due to the external attack or the error, the stability of entry energy system can be jeopardized. So to address this issue, we developed a diffusion model-based data purification technology. This technology actually focuses on the low frequency component of data, restoring distorted information while providing adaptive response to varying level of attack intensity. So next, on the slide, the diagram on the right visually explained how the technology operates. So this research has presented international conference, also is a top conference, IJCAI, also ICRA 2024. And it's expected to contribute to ensuring the data integrated in the real world energy system. Next one is I will introduce our research on the linear forecasting model based on the power time series data. So power data often contain a variety of external variables, making it essential to consider its distribution. So our research enhanced the performance by segmentation time series and data into patch unit, and then focus on the mitigating the distribution drift using adaptive token. So we combine the time loss and the frequency loss to maintain data constant. So from technical perspective, we achieved the robust forecasting performance by applying a knowledge transfer technique that expanded the short path token information to the entire data set. So as a result, our model actually demonstrates superior performance compared to existing state-of-the-art model, such as iTransformer and the patch TST and data set like ETT, exchange, and weather. Next, I will introduce also our research on the anomaly detection in the multivariate power time series data. Actually, in this study, we implemented the patch-based learning method to capture the temporal pattern while ensuring the proper data availability. The focus was on the maintaining the sequential characteristic of data to perform efficient anomaly data. So the proposed model advances the unsupervised anomaly detection technique into the supervised learning framework. We demonstrated that channel dependence strategy outperform that the channel independent strategy. So furthermore, the model run into the channel dependence and integrate diverse temporal information by adding relative positional bias. Using the transfer encoder with self-supervised learning, the model captures features the representation of data and perform demonstration downstream task using the anomaly augmented technique. So this batch-based learning framework has proven by highly effective in the domain of anomaly detection. Yeah, this slide actually we focus on the study addressing energy demand and supply with multi-energy router system. So the system was designed using various load renewable energy resource and the energy storage system, and each performance was evaluated through simulation. So the core of research involved simulating the interaction between diverse load and the renewable resource within the energy system, and then exploring optimization method to balance energy demand and the supply. So the architecture of the energy router system visualized the connecting among those components and demonstration how this design enabled stable and efficient energy management. So by applying these insights from the prior research to this simulation, we can significantly enhance the utilization of real-world energy. So we can, energy resource and optimize overall system performance. Okay, only I have 30 minutes. So next, I will introduce our research on the high-dimensional energy transformation from now. So this slide presents our research on the recommended system leveraging multi-behavior social energy data. So modern energy system encompass not only physical data, but also complex, multi-dimensional data like social energy data. So social energy data refers to the behavioral data generated when user engaged with specific production or service. So from the research, our finding the demonstration that Mule achieved up to 52% improved NDCG performance compared to the existing SOTA method, with the result published in the CIKM 2024 is one of the top conference. Okay. So next, let me introduce our research is pseudo labeling for multimodal model training. So modern energy systems are composed of large scale and then diverse data type, including power consumption data and state sensor data, and even visual data for energy management. So in particular, we're using the visual data from power plant or the distribution network to identify specific object and generate the descriptive the caption has to become increasing critical. So and then we approach the leverage pseudo label technique to accurate the identity object to energy data and generate unit. So this research also we get we presented on the ECCP 2024, one of the top conference in it. Okay, next. I only 30 seconds. So this study actually focused on the predictive technique and the large-scale solar power energy data. The source data set used the research include the result knowledge Austria Solar Center and then Open Energy Data Initiative, OEDI, so comprising 36 PICs, the PV array. as well as additional target data sets such as GIST, UK, power network, and the household data. Okay. Next, next three slides actually is related is natural processing, natural language processing. So I explained very shortly. Okay, so this one's interactive AI is increasing than being applied across the variety of field, and the energy sector is no exception. So in the smart home environment, it serves as a user interface, while in the large scale of factory and the commercial space. So it's our research focus on the improving the model efficiency through the context compression. So one major limit of the transformation model is the computation and memory requirement increase the drastically as into the ranks grow. So we tried one more time the encoding, like the DC AE, and then we improved the performance. Okay. Next. The interactive AI has recently seen extensive research aimed to addressing the hallucination, hallucination problem, which arises during the explanation generation process. So this study proposed a novel text generation method that reduces the hallucination while ensuring the both accuracy and diversity. The large language model often produces the output that factually incorrect and unsupported. So to mitigate this, we proposed a method that decomposes the generation text into atomic unit and applying parallel validation and the correction process. Yeah, actually, this is the last slide. So while previous research we focus on the input or range, this study actually addressed the improving dialogue quality of through the feedback. The earlier study were centered around the context. This research focused on utilizing the feedback document to enhance the response generation quality. So when generating response to the query using the large language model, LLMs, its answers are typically based on the input document. So however, the extended context range of often lead to limitations such as attention bias and reduce the response generated performance. So to address this issue, we proposed the document repositioning and feedback-based response to the generation method using creating model. The creating model evaluates the relevance between the initial response generated by the LLM and the input documentation. Based on this evaluation, the documentation document actually with high score repositioning to ensure that LLM attention is concentrated on them. So like this natural language process, how can we use in the energy? Like it's kind of we can use it some this some management system. So when the Korea Electronic Power Corporation, like the KEPCO or energy manager, make the decision based on the output of the energy language model, attention bias, and can lead to incorrect conclusion. So especially when the model has been trained to diverse data set. So like this technical knowledge leverage the correct model to prevent such a erroneous conclusion. Okay, I'm done. Yeah, thank you.
Thank you very much. Very interesting talk for Professor Jinsul Kim. Any question from the floor? So I have one. So among all those projects related to electrical energy and all the diverse energy, what's the longest term project? Or I may ask you, like, if not that within 2 to 3 years, what would you want to see the development for your domain to using actually AI even beyond the 5 to 10 years?
Yeah. Let's look at that slide. Yeah, thank you for a great question. Yeah, in the future, actually, our goal of this research, AI energy, is we wanna make some quantum net AI energy, like that on the center, in the bottom, is some more quantum net. That is actually using the some meta energy, virtual energy data, and then using that that virtual energy data, and we can get the prediction and management thing, and also some of knowledge data. This one can also making decision to help the making decision derived from the evidence. So also in the bottom also is, some of cognitive expansion data also. So we wanna this basically research is gonna together setting on the quantum net and energy AI. So that's gonna be using some for features of the human level energy. Also, the big goal is going to be green plant, in this our life, in our life. Okay, thank you.
Thank you for your answer. Let's thank Professor Kim again.